Okay guys, so today we're going to be continuing our study of applying systems of equations. So last week we were looking at system of equations and more review. We were looking at all linear examples. So that's why we had questions like, can a system have one, none, or infinitely many solutions? Today we're going to look at non-linear examples. So if you take a look at this picture, we could have like maybe a circle intersecting a line. And I have a vertical line here, but it doesn't have to be a vertical line. It could be any line. We have two circles intersecting each other, or we could have a parabola intersecting a line. So this is where we see we have some non-linear examples mixed in. And how can you solve systems of linear equations, like our aim? Well, we can still solve in two ways. We can solve it graphically, like these are solved graphically. I can see the points of intersection. Or we can solve algebraically. Now, algebraic is what we're primarily going to focus on throughout this video. But our graphical knowledge we will be going back to. One part about our graphical knowledge I'd like to point out now is that on Friday's lesson we talked about having one, none, or infinitely many solutions. Well, already in these cases I see another option. I could have two solutions for nonlinear cases. So we could have one solution, no solutions, or we could have maybe two solutions in these examples. So we'll cover that a little bit more throughout the video. Now, if I want to determine the intersection between a circle and a line. So here's a circle equation, and here's a line equation. It has a vertical line x equals 5. If I want to try to figure out where does that vertical line intersect the circle, well, we can solve using the substitution method. Now let's ask ourselves, why the substitution method? Well, x equals 5. I have a variable already isolated by itself. So therefore, it would lend itself very easily to substitute that x value into the other equation. So let's do that. We have 5 minus 2 squared plus y minus 2 squared equals 16. Now, to finish solving this problem, we're going to do some mental math, and by all means, you can pause and calculate this on your own and click play to check your work. This is 5 minus 2 is 3, and 3 squared is 9. Now, some of you guys might be prompted to try to do like your binomial multiplication, or what you guys sometimes call foiling on that part right there. We don't need to do that for this particular equation, so don't do that. We're going to subtract 9 from each side. We get y minus 2 to the second power equals 7. Now, we're trying to solve for y. So I'm going to take the square root of each side. The square root and this exponent will cancel each other out. We have y minus 2 equals positive or negative radical 7. Notice including this positive or negative part. When we take the square root of each side of an equation, when we're solving an equation algebraically, if I take the square root of both sides of an equation, I need to include this plus or minus sign. And it's actually very important for this example, because as we finish off, we're going to add 2 to both sides here. So if we add 2 to both sides, I'm just going to write my answer up here on the right-hand side. I have y equals 2 plus or minus radical 7. It's very important that we have this plus or minus portion because we actually have two solutions to the system. Now remember, our solution is an ordered pair. It's a point of intersection on the graph. So our ordered pairs are actually written like this. And we'll review why, or what this means. These are the ordered pair. Now, we could come up with some decimal equivalent of the square root of 7, but typically we leave it in exact form. So we're going to leave that as 2 plus radical 7, and down here we leave it as 2 minus radical 7. Remember, that's just a number. It's just a number that I don't want to calculate the decimal approximation. So we're leaving it as exact form. These are the 2 points of intersection that this line intersects with that circle. Right? Notice the x value is both 5, going back to that line of x equals 5. All right? Now, continuing with our notes, we can look at some other examples. So, our next example, almost lost the page there. Our next example, we can try to come up with the coordinates of the intersection between our line x equals negative 7 and this circle given by this equation. And later on, we're going to ask about, is it tangent or secant? We'll explain what that means. So, continuing on, I know x equals negative 7. I'm going to plug that back in. Now, having that plugged into the equation, now we're going to simplify and solve. I can see negative 7 plus 3 is negative 4, and negative 4 squared is 16. Subtract 16 from both sides, and we have y minus 2 squared equals 9. Then take the square root of each side. Y minus 2 equals plus or minus 3. Notice we include that plus or minus in there as well. Adding 2 to both sides, we have y equals 2 plus or minus 3. Now I'm going to write this as a number in a second. I'm just trying to emphasize this plus or minus part. Our ordered pair solution, okay, because we're going to be able to do 2 plus 3 and 2 minus 3 in a second. Our ordered pair solution is negative 7, 2 plus 3. That's 5. Our other ordered pair solution is negative 7, 2 minus 3. That's negative 1. This is our 2 ordered pair solution. Now, the follow-up question is this line tangent or secant to the circle? It is secant to the circle, and let's explain why, and let's review some vocabulary. Tangent and secant. You might want to jot this down. Tangent. If a line is tangent to a circle, or if a circle is tangent to a line, you might have heard that phrase before. Tangent means one intersection. Secant means 2 intersections. If we were to graph this, we would see that 2 intersections, so it's secant to the circle. Secant to a circle also means that that line would form a chord, meaning it would pass through. It doesn't pass through the middle. That would cause, we would think of it as a diameter. But this would be secant to the circle, meaning it has 2 points of intersection. Okay? Carrying on, we can now look at an example of a parabola and a line. And we'll look at a graphing example of this one as well. Now, we want to solve the problem algebraically to start. Notice that I have y equals form for one of my equations. That's the equation of the line. Well, y equals something. That's a good idea to use substitution. So I'm going to plug this equation into this y onto the other equation. Solving, and this is a good review of your algebra skills. I'm just going to pause real quick. Remember, we would have to get everything to one side of the equation. Those are not like terms, so they don't combine. We're going to solve by factoring out the GCF. In this case, it's x. Now we have a problem in factored form. According to the zero product property, I can set each of my factors equal to 0. Therefore, x equals 0, that's already solved, and my other solution is 4 equals x. Notice I have 2 x solutions. This is implying that I have 2 points of intersection. This is only the x coordinates. I still need the y coordinates for an ordered pair. In order to figure out my y coordinates, I can take my x values and plug them back in. I can plug this into either equation. It doesn't matter. I'm going to stick with a linear example because it's probably a little bit easier to substitute and solve there. But let's plug that in. Y equals 1 times 0. So y equals 0. Y equals 1 times 4. So y equals 4. Therefore, my ordered pair solutions are from right here, right in this middle spot right here. 0, 0, and 4, 4. Those are our ordered pair solutions. To graph that, we could graph our linear line. Now, you guys can use a straight edge. I'm just freehanding this. If you want to get a straight edge, that might help. Our parabola is graphed. Now, you can graph your parabola using a table of values or any type of graphing device, but one easy trick might be in a table of values, XY table of values. I'll use these 3. If I plug in negative 4, I'm going to plug it into this equation. I plug in negative 4. I'll let you guys do the math, but these are the 3 ordered pairs you would get. 0, 0, 4, 4, and -4, -4, forming this parabola. Notice the 2 points of intersection here and here, and those are our 2 answers that we got in our original problem. All right, 2 more examples, or really 1 more example, and then we're going to wrap this one up. Determine intersection between a circle and a line. Now, this is a non-vertical line. This is like a line almost like how we graphed before, just kind of like a line we'd picture in our head when we say graph a line. So we're going to take this value of our linear line, y equals x minus 3. I'm going to take that and plug that in to the other equation. X plus 1 squared plus x minus 3 plus 2 squared equals 16. So see how I just replaced this y value with my other equation. This, you might want to jot that down, would simplify to be x minus 1, by the way. And we just simplify within those parentheses. Now, in order to solve for my point of intersection on this problem, I would have to now do my binomial multiplication or my foiling for each of these parentheses. X plus 1 squared becomes x squared plus 2x plus 1. Now, I'm just keeping these parentheses just to separate them. We don't really need the parentheses at this point, but I'm just trying to emphasize like the 2 different groups. X minus 1 squared is x squared minus 2x plus 1. It's still all equals 16. Now, it would be best to combine our like terms. Combine our like terms, we have 2x squareds, 2x and minus 2x cancel each other out, and 1 plus 1 is 2. Now we're at the stage where we're almost ready to solve. To solve, first I might want to factor out a GCF. Look like this. Now, some of you guys just are in the habit of dividing everything by 2 right away, and that would have been fine. I'm just doing this extra step here to emphasize how we're factoring out that GCF. If you divide both sides by 2, I'm going to just move over to the right-hand side for a little more room. We have x squared plus 1 equals 8, or x squared equals 7 when we subtract 1 from both sides. The final step would be to do the square root of each side, and x would equal positive or negative radical 7. That would be your x coordinates for your solution. To figure out your y coordinates, I just have to plug that back into the linear equation. Now, I am not going to get an actual decimal answer. I'm going to leave my answer as a radical form or an exact form. So my solutions would be square root of 7 and then the square root of 7 minus 3. That's just a number. I'm just leaving it in this exact form as opposed to a decimal approximation. And my other answer is negative radical 7, comma, negative radical 7 minus 3. Okay, I'm getting the y values by taking my x values and plugging it into my original equation. Okay, I'm going to leave this next problem as an extension problem for you guys to try on your own. We're not really going to do a problem like this on the homework or on our future quiz, but this would be a good chance to challenge yourself to see if you can come up with that answer. And I'll post the answer to this problem a little bit later on. All right, good luck, guys, on today's assignment.